Alright, ladies and gentlemen, this is the quiz for review packet. We're going to go over each problem step by step to make sure you feel nice and comfortable with the material. If you have any questions, please come to Extra Help. I'll be happy to help you out. Alright, so the first problem we got here is this one right here. We have an exterior angle outside this triangle of 110, and the two interior angles are 6x plus 10 and 3x plus 10. Notice these angles, they're not the adjacent angle to this exterior angle. It's the two opposite angles of the triangle. So anytime we're given this situation, we could combine like terms of the two interior angles, the 3x and the 6x and the 10 plus 10. We combine our like terms here. We combine this angle and this angle together, so we get 9x plus 6x, which is, 3x plus 6x gets you 9x. That'll be 9x plus 20. So we're going to write out 9x plus 20, and that's going to be equal to the exterior angle of 110, which is this guy right here. That's the exterior angle. So it's equal to 110. We then do our inverse operations of subtract 20 from both sides, and then we get 9x equals 90. Divide by 9 to both sides, and you get x equals 10. And that's what we're asking to do here in problem number 1, is to solve for x. Find out the x value that'll make this true, meaning that the exterior angle is equal to the sum of the two interior angles. That's not the supplementary angle. That's problem number 1. Next up is problem number 2. Our exterior angle right out here is the 6x plus 21. That's our exterior angle. The interior angles, or inside the triangle, is 5x plus 11 and 21. We're going to combine the two interior angles, combine our like terms just like we did in Algebra 1. So 5x plus nothing gets you 5x, and 11 plus 21 gets you 32. So we're going to say 5x plus 32 is equal to that exterior angle, which is 6x plus 21. Then we're going to do our inverse operations. We're going to subtract 5x from both sides. So then we're going to get 32 is equal to 1x plus 21. That's what happens when you subtract 5x from this side and 5x from this side. And we learned that in Algebra 1. And we have variables on both sides. Then we're going to subtract 21 from both sides. So we subtract 21 there. And you subtract 21 there. You're going to get 11 equals 1x, or aka 11 equals x, or x equals 11. And we solve for the value of x. So we have x equals 11. That's the answer number 2. Number 3. Our exterior angle is this guy right here, 14x minus 6, because that's on the outside of the triangle. And our two interior angles, the inside of the triangle, are located here and here. That's 4x and 104. So we say 4x plus 104 equals 14x minus 6. Once again, we have variables on both sides, which you talked about in Algebra 1. You're going to subtract 4x from both sides. So you get 104 equals 10x minus 6. We add 6 to both sides. So you're going to get 110 equals 10x. And then you divide by 10 to both sides, and you're going to get x equals 11. Then that's how you do problem number 3. Problem number 4. Our exterior angle is 140. That's right there on the outside. The interior angles are 27x plus 2 and 2 plus 7x. We're going to combine our like terms. 27x plus 7x gets you 34x. So that's why we type 34x. And 2 plus 2 gets you 4. So we combine those constants. It's equal to that exterior angle of 140 degrees. We then do our inverse operations. We subtract 2 from both sides, and we get 34x equals 138. And then we're going to divide both sides by 34. And we're going to get x equals... Let's put that in a calculator. 138 divided by 34. We have 4.05. Let's see if I made a mistake somewhere. Oh, because I typed in plus 2, but it was 2 times 2, so it's a plus 4. And when you subtract 4, it gets you 136. And then when you divide that by 4 to both sides, or 34 divided by both sides, you get x equals 4. That makes more sense. So number 4 is x equals 4. Let's move on to number 5. So, the exterior angle is the 20x minus 2. The two interior angles are 48 and 6x plus 6. You're going to combine the two interior angles. You combine your like terms just like you did in Algebra 1. So 6x, well there's no other x's there, so it's going to be 6x plus 48 plus 6 gets you 54. And that's equal to the exterior angle of 20x minus 2. We do our inverse operations. I'm going to subtract 6 from both sides, or 6x I should say, from both sides. So 20x minus 6x gets you 14x. Then I'm going to add 2 to both sides, so I'm going to get 56 equals 14x. And then 56 divided by 14, that would be 6. Oh, wait a minute, nope, that would be 4. Because 56 divided by 14 gets you 4, so x equals 4. That's the answer to number 5. Let's move on to number 6. Find the interior angle sum for each polygon. Round your answer to the nearest tenth if necessary. So to solve these problems, I count the number of sides. I'm going to put a little red dot to help remind me. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. There's 11 sides. Now to find out the total sum of the interior angles, I got to use the formula of n for the number of sides minus 2 inside those set of parentheses times 180. So since we have 11, it's going to be 11 minus 2. So parentheses 11 minus 2 times 180. 11 minus 2 gets you 9, so it's going to be 9 times 180. And 9 times 180, bring up the calculator, and we get 1,620. So 1,620 would be the answer. That's the answer number 6. Number 7, you have 4 sides, so 4 minus 2 gets you 2. 2 times 180 gets you 360. So for number 7, it's 360 degrees. Number 8, classify each triangle by its angles and its sides. Well, in your notes, I told you how do you classify an angle, a triangle to be acute, right, or obtuse by the angles. And we also told you how to classify a triangle by its sides. So let's first talk about angles. If all 3 of these angles, these interior angles of 24, 90 and 66 in this case, if all three of these angles are less than 90 degrees, then you have an acute triangle. If one of these angles is 90 degrees, you're going to have a right triangle. So I already know, since it's a right triangle, it's not an obtuse equilateral and it's not an obtuse scalene. So I could cross out A and B. I have a right triangle. Now, is it a right isosceles or scalene? Well, to figure out this word is we have to refer to the sides, which is 21.1, 23.1, and 9.4. Since all three sides are different, they have different numbers, it is considered a scalene triangle. So my answer for number 8 is a right scalene triangle. Number 9, we do the same process. We see the interior angles are 78, 40, and 62. They're all less than 90. So we're going to have an acute. We're not going to have an obtuse, and we're not going to have a right triangle. Now we're going to have to figure out the sides here. The sides are 3.3, 4.5, and 5. All three sides are different. So this is going to be a scalene triangle. So it's an acute scalene, which is option B. So number 9 is B. Number 10, we look at the inside angles. We have 36, 23, 121. Since we have one angle that's bigger than 90 degrees, that means we have an obtuse triangle. So anytime a triangle has an angle that's bigger than 90 degrees, just one that's bigger than 90 degrees, we have an obtuse triangle. Now we have 1, 2, 3 different side lengths. Since there's 3 different side lengths, it's going to be a scalene triangle. So number 10 is C. Number 11, we look at the side lengths. 2 out of the 3 side lengths are the same. So that means we have an isosceles triangle, so it definitely ain't A, because they're telling us it's equilateral. So it's an isosceles. Now to find out what type of isosceles, we look at the inside angles. 55, 55, and 70. They're all less than 90 degrees. So it's an acute isosceles triangle for number 11. Number 12. All the inside angles, once again, are less than 90 degrees, so we have an acute triangle. And 2 out of the 3 sides are the same, so it's isosceles. So we have an acute isosceles. 12 is A. Number 13, we have an angle that's bigger than 90 degrees, so we know it's obtuse. 2 out of the 3 sides are the same, so it's isosceles. So we have an obtuse isosceles triangle for number 13. Number 14, state if this triangle is acute, obtuse, or right. We go about doing this is by figuring out each measure. So the square root of 127, let's find out to see if that's the biggest. So second square root, 127. The square root of 127 is 11.26. And that's clearly not the biggest one, 11.26. The biggest one is 14. So now what we're going to use a squared plus b squared equals c squared, where the biggest value always goes in for c. So it's going to be 8 squared plus, so we have 8 squared, I'll bring that right up, 8 squared plus the square root, so I do parentheses, square root button, 127, close parentheses, square it, and it's equal to 14 squared. So a squared plus b squared equals c squared, where c squared is always the biggest one. Now we crunch this number out. 8 squared is 64. So we're going to have 64 plus the square root of 127 squared, which is just 127. And it's equal to 14 squared. 14 squared is 14 times 14, which is 196. 127 plus 64 gets you 180, 191. 191 is less than 196. Now, anytime a squared plus b squared is less than c squared, our triangle is going to be obtuse. It's going to be an obtuse triangle. So anytime c squared is bigger than a squared plus b squared, we have an obtuse triangle. That means this big length is really that extremely big. So that means this angle here is going to be bigger than 90 degrees. So this angle right here is going to be bigger than 90 degrees because 14 is significantly bigger than these two put together. Next up is number 15. We find out what the square root of 33 is. We're going to find the biggest numbers of the square root. That's 5.7. And square root of 19 is a little bit smaller. So square root of 33 is going to go all by itself. And a squared plus b squared equals c squared. So we're going to do 4 squared plus square root of 19 squared is equal to the square root of 33 squared. We're going to crunch this out. 4 squared is 16. Square root of 19 squared is just 19. It's just itself. And the square root of 33 squared is just 33. 16 plus 19 gets you 35. So we have 35 is greater than 33. Now when a squared plus b squared is bigger than 33, we have an acute triangle. So the answer to number 15 is acute. Number 16. 16 is the biggest number of these three numbers. So I'm going to put 16 by itself. So a squared plus b squared equals c squared. Square root of 65 squared plus square root of 191 squared is equal to 16 squared. Make that all in one line. Cool. Square root of 65 squared is just 65. So we're going to have 65 plus 191 squared is 191. And 16 squared. Let's double check that on the calculator. 16 squared is 256. 191 plus 65. 191 plus 65 get you 256 also. So 256 equals 256. When the numbers are equal to each other, when the number on the left is equal to the number on the right, when a squared plus b squared is equal to c squared, that means we have a right triangle. So the answer to number 16 is right for a right triangle for number 16. Next up is number 17. The biggest number of these threes is the square root of 223. So that guy's going all by itself. We're going to do the same thing that we just did for the past three problems. So it'll be 14 squared plus square root of 30 squared is equal to the square root of 223. Squared. All right. So that's our formula. Stretch it out so it's all in one line. Cool. So 14 squared is 196. Square root of